Okay, do you remember what we were talking about yesterday? Okay, we're getting started now. We're getting started. So yesterday we started talking about something different, right? Not coding. We started talking about modeling. All right. Now, usually modeling, well, like modeling can be used in any stage in the software development life cycle, but usually used in the design. Okay. We started talking about some of the diagrams in the UML language. Do you remember what is the what does UML stand for? So L is a language, right? So that's the easy part. Yes. Yeah, the unified modeling language. So this is language that mostly graphical, consists of a set of diagrams to describe certain aspects of a system, particularly we're talking about software system. Okay, and we mentioned that there are two main categories. One of them is the structural category, and we talked about one of the structural diagrams, which was the class diagram. That's what we talked about yesterday, right? Now today we are going to talk about two of the behavioral diagrams. So the behavior group of diagrams describe behavioral aspects, so dynamic aspects of the system. So this dynamic axis, there's a subcategory here that's called interaction. That is the interaction between components or objects, depending. So communication diagram, for example, or interaction overview diagram. Well, the ones that we're gonna talk about today are the sequence diagram, that is the part of the subcategory, the interaction category, and the activity diagram. Now you might recognize the activity diagram because it is used in other disciplines as well. It's not specific to software, so but it's definitely useful for software modeling as well. So we start with the interaction sequence diagram. Now, what are we talking about? Who's interacting here when we are talking about sequence diagram? Mainly the object in the system. So when we create classes, and then we create objects out of these classes, right? Now, how these objects interact, we can describe that in several diagrams. One of the most popular of them is the sequence diagram. Okay, now how is that? Now, every diagram has certain components. It's like when you have a language, you have, say, verbs, you have alphabets, and you have, structure of the sentence. So when you have a diagram that is part of a language, you want to know what is it that can be depicted on a diagram. So on an interaction diagram, you would have objects, operations, and messages. Well, in the sequence diagram, it illustrates how the objects participate in a use case or an action or an event. So you have something, you are writing code for some event to do some action. Okay, and this code that you're writing, you already define the classes and you have the objects. Now, or maybe you don't really know when or how the objects are going to be created and how they are going to interact. So the structural diagram, the sequence diagram help you do that. So first of all, it illustrates what are the objects involved in a certain interaction or event or use case, and shows the messages. So remember when we talked about the object-oriented principles, and we talked about the concept of message passing? Do you remember that? So what is message passing? A concept in object-oriented principles that's called message passing. What does it mean? It's pretty much function call, but a function that is called through an object. So when you say an object, ask to start with an object and then use a dot operator and then call a method defined as part of this object. This is what the message passes. So this call is like sending a message to that object. Okay, so that's a very important aspect that appear on the sequence diagram as well. So what are the notations? So this is pretty much the syntax. So first, we may or may not have action. Okay. Now, as you remember, it's supposed to be standard, but it's not really that strict. So you look at different text boxes, you will find variations in the notation and the variation in the syntax. And generally speaking, we are describing the same thing. Now, sometimes an actor can appear in a class diagram, in a sequence diagram, if you are describing the interaction from beginning. So if you have a user interface and you want to describe the interaction from the user event, so a user clicked the button or a user sent some information. Okay, so if you want to start from there, you can have an actor that appear on the sequence diagram. What is really essential and common between all the descriptions of the sequence diagram is the object. So it appears as a box. Now that you can put the name of the object or not, but you have a column and then a class. So you say this box represents an object of that class. Okay, or sometimes you can omit the name of the object because that's pretty much determined in the code. Now we're talking about this stage is describing the code before it's written, or sometimes you can use it also to describe written code to illustrate it or to communicate it. Okay, so you can include the name of the object or not. What really matters is that the column to describe, to emphasize that this is an object, and the class name, so to emphasize that this is an object of that particular class. Okay, and then there's a lifeline, this dashed vertical line, that's how long this object exists in the system since the creation, the instantiation of the object, and then eventually when you get to destroy it or to delete it. Even though this symbol is not really meaningful much, because most languages now don't allow you to destruct an object, it gets destructed automatically. But you can use it to describe that this object should not exist anymore. All right, now the box that would be added to the lifeline that indicates that this is the duration of execution of a method, or the execution frame since we send the message, so the method call, until the end, so until the return of that method. Okay, so that's the execution frame. Now a message is just pretty much a method call, a function call. Okay, that's what the message is. So the call itself is depicted as a solid line from the caller to the callee. And if there's a return value, it would be depicted as dashed line from the method itself to the caller. Okay, so what after the method ends, what value would return? Well, over time, this would be omitted in order to reduce the clutter on the diagram. But if what returns is not obvious, then you should add it. Otherwise, if it's obvious, then you should omit it because it will make the diagram very busy, very cluttered. Okay. Now it is possible to add a condition on the message line. Okay, so it's called a guard condition. And when you get to implement that, you don't call the method right away. You just need to add an if statement to implement that guarding condition. Okay. And then the object destruction, if you need to emphasize that the object needs to stop appearing or stop existing, you can use this X on the lifeline to end it. And you can also add a frame. You can use this frame to add any context around any parts of the diagram or the entire diagram to describe certain context. Okay. So this is the syntax. This is the language, the elements in on the syntax of the sequence diagram.